Okay, my name is Engineer Kingsley. I'm speaking from Old Teachings. Thank you for always being with us in this channel. We always give you the best. Today we'll be talking about trigonometry. Trigonometry is derived from two Greek words. The first one is what we call trigon, and the second is what we call metron. Metron. Trigon means triangle, and metron means measurement. Measurement. Okay, that means that trigonometry is a branch of mathematics that deals with the study of triangle or angles and its measurement. So, the next thing we are going to talk about is the basic trigonometric signs. The basic trigonometric ratios is what we call the sine, which is generally referred to as sine theta. We can say sine alpha, we can say sine beta, we can say sine x, anything. But we are talking about sine, cosine, which is cos theta, and we have tangent. Tangent is tan function, which we call tan theta. This is the basic three trigonometric ratios. Then, the second thing we are going to talk about is what we call inverse of trigonometry. Inverse of three functions is basically divided into three. The first one is what we call the secant of angle theta, secant of angle theta. The second is what we call cosecant, and thirdly we have cotangent of angle theta. Second of angle theta is talking about sec theta, which is concentrating in the third letter. Inverse is 1 all over what we are talking about. C means cos theta. So 1 all over cos theta is the same thing as sec theta, which is secant of angle theta. Then the second one is what we call cosecant, which is called cosec theta. We count 1, 2, 3, the third letter, we are talking about 1 all over sine theta. Then lastly, the cotangent is what we call cos theta, which is 1 all over 1, 2, 3, which is 1 all over tan theta. Okay, this is the basic trig functions, and these are the inverse of the trig functions. Okay, there is this young man, there is this French mathematician, a German philosopher, a French philosopher that said his name is Socrates. This is the full name that is basically divided into three according to trigonometry. And this man's name was proved using a right angled triangle. A right angled triangle is that triangle that is forming a perpendicular angle, and perpendicular is 90 degrees with a separating angle of theta. If we have here to be A and here to be B and here to be C, the place that the capital A is facing is the small a, the place that the capital B is facing is the small b, the place that the capital C is facing is the small c. The longest side of a right angle triangle is what we call the hypotenuse. The place that the angle or the theta is facing is what we call the opposite. Then the place that the angle is not facing is the adjacent. Okay. So this so is telling you, the first division is telling you that x stands for sine theta, and sine theta is opposite all over hypotenuse. And opposite here is side AB, and hypotenuse here is side AC. And side AB, which is the opposite, is small letter c, and side AC, which is hypotenuse, is small letter b. Okay? So, if we want to talk about the second division, which is Cal is telling us that we are having cos theta, which is the first one, and cos theta is adjacent all over hypotenuse, and adjacent is side BC, and hypotenuse is side AC. Adjacent is small letter A, all over hypotenuse is small letter B. Then the third one is tan theta, and tan theta is opposite all over adjacent. Opposite is side A, B, and adjacent is side BC. Then opposite is C all over, adjacent is A. So you have to note all these sides because when we'll be treating bearing and distance and angle of elevation and depression, we'll still be noting all this. Okay, the next thing one have to put into consideration is what we call spatial angles. Spatial angles is basically divided into two. Spatial angles is basically divided into two. The first one is what we call the major angles, and the second one is what we call the minor angles. The major angles are the angle 30 degrees, the 60 degrees, and the 45 degrees. While the minor angles are all those angles that are not measured, which have example of 0 degrees, 90 degrees, 180 degrees, 210, 270, 360, dot, dot, dot. Any angle that is not major, these three, is categorized under minor angles. And these major angles is being proved. The angle 30 and 60 is being proved using an equilateral triangle. Is being proved using an equilateral triangle like this, since the sum of angle on a triangle is 180 degrees. You have here to be 60, here to be 60, and here to be 60. 60 degrees, 60 degrees. Sum of angle on a triangle is always 180. Okay, if I have here to be my x, I have here to be my x, I have here to be my x. All of them are same because all of them are equal because it's an equilateral triangle. If I decide to bisect means divide. Bisect this triangle into two equal halves and bring out one. There's something that we are going to get as a result in this triangle. It will give us what we call right angle triangle. Let's watch and see what will be the outcome. Right angle triangle in the sense that we have something that looks like this. Okay? Where here is the 90 degrees formed, here is still my x, here is still my 60 degrees angle. Then this one was previously 60. Well, when I bisected it into two, it shared the 60 into two to give us 30 remaining here. Then the horizontal was previously x, but when I divided it into two, it changed to half x. So this is the place we are looking for. Let me call it h, the height of the place that I bisected. So I have to get this the place that is unknown using what we call Pythagoras theorem. Pythagoras Pythagoras theorem. Pythagoras theorem said that hypotenuse squared is equal to opposite squared plus adjacent squared. Okay? Here is the hypotenuse, which you are having x squared equal to, this can be the opposite, this can be the opposite because the theta angle, theta is in both sides. So you can choose any one, I can use h, I can use this. So plus adjacent is x all over 2 all squared. Okay? We have x is the same thing as x all over 2 because x is having denominator of 1. 1 times x will give us x all over 2. So our aim is to make h the subject. Then this have to come to the other side. Then we have that h squared is equal to h squared is equal to x squared that is here. This is positive. It is causing to change to negative. But according to indices, this is affecting the numerator and the denominator. When it comes to x, change it to x squared. When it comes to 2, change it to 2 squared, which will give me 4. Our aim is to make h the subject, which is what we are going to do here. Okay? So please keep in touch with us as we conclude this. We are doing nice work here. Okay? We have the denominator as 1 and want to find the LCM. The LCM of 1 and 4 is 4. 1 into 4 is 4. 4 times x squared is 4x squared minus 4 into 4 is 1 times x squared give us x squared. So when we want to get, we have h squared is equal to 4x squared minus x squared is 3x squared all over 4. So to make h the subject, we take the square root of both sides. Our square root of 3x squared all over 4. This we cancel this. H will be equal to, the square root is affecting the numerator and affecting the denominator. So you have that h is equal to, this affecting the x squared and affecting the 3. You have x on 3 all over. So 4 is 2. So here, the value of h becomes x sub 3 all over 2. So we can evaluate our angle. So the new thing, right angle triangle we're having now that we're using to evaluate is looking like this. Here is x, here is x all over 2, here is x sub 3 all over 2. Okay, here is 60 degrees and here is 30 degrees. Okay, let's write 30 first to evaluate this. Okay, if we have something like this, we are talking about angle 30 degrees, sine 30. Sine 30 is, sine is opposite over hypotenuse. If 30 is here, that means here becomes the opposite, which is x all over 2, divided by the hypotenuse, which is x. Remember, here is over 1. So I will have that x all over 2 multiplied by 1 all over x. X will go with x. Finally, I will have 1 all over 2 as my sine 30. So if you are talking about cos 30 degrees, you are having adjacent, which is x sub 3 all over 2 divided by the hypotenuse, which is what? X. So remember, here is over 1. I'll have x sub 3 multiplied by 1 all over x. X will go with x. Cos 30 will be sub 3 all over 2. Then tan 30 degrees is going to be adjacent, which opposite all over adjacent, x all over 2 divided by x sub 3 all over 2. So I have to change this to multiplication by having x all over 2 multiplied by 2 all over x sub 3. X will go with x, 2 will go with 2. Finally, I will have 30 to be 1 all over sub 3. Or by rationalization, I will have that 1 all over sub 3 multiplied by sub 3 all over sub 3 will be giving me 1 times sub 3 will give me sub 3 all over. So 3 times sub 3 will give me 3. So another way of writing tan 30 is sub 3 all over 3. Okay? So that is for spatial angle for 30 degrees angle. We can evaluate that of the 60 degrees. Okay? That of the 60 degrees, when we are having something that looks like this, is we are having angle 60 and the 60 degrees will be giving me start from sine 60. Sine is opposite all over. If 60 is here, here becomes the opposite. So 60 will give me x sub 3 all over 2 divided by the hypotenuse, which is x. Remember, here is over 1. We have x sub 3 all over 2 multiplied by 1 will go up, x will come down, x will cancel x. I will be having sine 60 to be sub 3 all over 2, similar to cos 30. So you get it now. So when you are talking about cos 60 degrees is cos is adjacent all over hypotenuse. If 60 is here, here becomes the adjacent, which is x all over 2, divided by the hypotenuse, which is what? X all over 1. So we now have that x all over 2 multiplied by 1 all over x. X will cancel x. Finally, I will have 1 all over 2, which is similar to what? Sine 30. So cos 60 and sine 30 is the same, while sine 60 and cos 30 is the same. So in other words, we talk about tan 60 degrees. Tan 60 is opposite, which is x sub 3 all over 2, divided by adjacent, which is x all over 2. You have x sub 3 all over 2 multiplied by 2 all over x. X will go with x, 2 will go with 2. We'll now have sub 3 as my answer, which is directly inverse or reciprocal of the tan 30. So tan 30 is 1 over sub 3, while tan 60 is sub 3 all over 1. Okay, the last one is partial angles that we're going to talk about is angle 45 degrees. Angle 45 degrees is proved using an equilateral triangle, using an isosceles triangle. An isosceles triangle is that triangle that the two base sides are equal. So if we have a triangle that looks this way, where here is equal with this one, if I call here x, I will call here x. Let me call here y, assume that here is bigger than this pole, because in an isosceles triangle, the two base sides are equal. And you have a right angle triangle here, where this is equal with this. So using Pythagoras theorem, we know that hypotenuse squared is equal to opposite squared. This can be the opposite, this can be the opposite. Opposite squared plus adjacent squared. So we now have that y squared is equal to x squared plus s squared will give me 2x squared. So taking the square root of both sides to make y the subject, we have 2x squared. This will go with this. Oh, sorry. This will go with this. Y will be equal to affecting the 2 and affecting the x squared will give me x sub 2. Okay, so the value of y here is x sub 2. With this, we can evaluate the three ratios of tan 45 sine 45. Sine 45 degrees will now give me opposite all over hypotenuse, which is this can be the opposite, this can be the opposite. X divided by the hypotenuse, which is x sod 2. X will go with x. Finally, sine 45 will be 1 over sod 2, or sod 2 all over 2 by rationalization, as I said in the previous class. Okay? So when you talk about cos 45 degrees, you are still having adjacent, which is x divided by hypotenuse, which is x sod 2. This we cancel this. Finally, I'll have 1 all over sod 2. So cos 45 and sine 45 is the same. Or you still know that it's sod 2 all over what? 2. Okay? Then for tan 45 degrees, we have that is opposite all over what? Adjacent, which will give you 1. That's the reason. Anytime you punch in your calculator tan 45, you always get 1 as your answer. So this will be the end of spatial angles. The next